Next one is first come, first serve CPU scheduling. First come, first serve FCFS is an operating system algorithm that works on queued requests and implements them according to their arrival. Now, the Fibonacci heap. Fibonacci heap is a data structure that implements priority queue operations consisting of the collection of heap order trees. Now, our last segment, that is the comparison between stack and queue. So at first, both stack and queue are linear data structures, and stack follows last in, first out, whereas queue follows first in and first out. And when you're considering stack, the insertion takes place at the top and deletion takes place from the top as well. Whereas when it comes to stack, the insertion starts from rear, but deletion or elimination of the element from the queue starts from the front. In stacks, the insert operation is called as push and deletion process is called as pop. In queues, the insertion is called as NQ and deletion is called as DQ. In stacks, we mainly maintain one pointer to access the list, that is called top, which always points to the last element present in the list. In queues, we maintain two different pointers. The first one is the front pointer, which always points to the front element or the first element inserted in the list. And the next one is the rear pointer, which always points to the rear or the last element inserted into the list. Stack is used in solving problems that work on recursion, whereas queue is used in solving problems having sequential processing. So these are the fundamental differences between stacks and queues. In this session, we will learn about linear search algorithm, its complete logic, and how to program and implement it in real time. Now let us try to understand what exactly is searching. Searching in data structure refers to the process of finding the desired element in the set of items. The selected item is called the target element. Any data structure such as an array, linked list, tree, or graph can be used for searching a set of elements. In data structures, searching can be categorized into two types. First type is the sequential search, in which we check the elements in a data list or an array one by one. In data structures, searching can be categorized into two ways. The first type is a sequential search, in which we check the elements in a data list or an array one by one. An example for sequential search is linear search. Now, let us learn about the next type of searching approach. The next type of searching approach is the interval search approach. Interval search divides the search in half by repeatedly targeting the center of the dataset. The binary search algorithm can be an example for interval search. We will go over the binary search algorithm in detail in our upcoming video. After understanding the logic of search and the types of search, we will get into understanding what is linear search algorithm. The linear search method is a simple search technique. In this type of searching approach, we perform a sequential search across all objects one after the other. Every element is examined, and if there is a match found, then the specific element is returned. Otherwise, the search will continue until the data gathering is complete. Let us go through an example for better learning experience. On my screen, we have the following elements: 50, 10, 20, 30, 70, 40, 90, 60, as randomly distributed elements. Let us imagine that our target element is 70. We found that our target element was 70 using linear search strategy. So, how does it work? In the next segment, we will look into the working terms of linear search algorithm. The simplest method of searching the data collection is the linear search. Starting from the beginning of the dataset, each element is examined until no match is found. The linear search is completed after the item has located. In the first stage, we compare the first element, that is 50, to the searched element, that is 70. We will go on to the next element because 50 and 70 are not matched. We will compare the second element, which is 10, to the search element, that is 70, in the next step. And once more there is no match found. Then we have the element 30 as the next comparison, and 70 and 30 are not matched. We have the next element, that is 20, in the fourth phase, and there is no match when we compare 20 with 70. Moving on to the following stage, we have the data element 70, and after comparing 70 with the search element, there is a match. We will now have the searching and display index as for, and this index contains the searched element. We now comprehend the pseudocode of the linear search algorithm after learning the working terminology of linear search algorithm. First, we have a function called linear search which has two variables in its parameters, the array's name, which is an array, and the search variable, which is the value. Then, using a for loop, we must search for our target variable by analyzing all the data elements in the dataset with the condition that is the searched item is identical to any set's value. We must return its index value. Now, we must stop searching once the searched value has been discovered. Then we will close our if